Welcome to the Explainer. Today, we're diving into something that's honestly a huge balancing act for educators and parents alike, figuring out exactly how the St. Paul district handles the boundary between grade 7 core math and accelerated Algebra I enrichment. It's a tricky balance to strike, right? You absolutely want to challenge your most ready students, but you literally cannot afford to skip the foundational steps that make higher-level math possible. So we're going to break down how this curriculum is structured to hit both of those goals effectively without leaving anyone behind.
Here is our roadmap for today. We will define the algebra boundary, look at the pacing guide, do a deep dive into linear systems, and then wrap up with real-world contexts and common mistakes.
Section 1. Defining the algebra boundary and protecting the core curriculum. Let's establish exactly what this enrichment means.
All right, so the golden rule here is simple but totally non-negotiable. Algebra I enrichment does not replace the grade 7 core. Think about proportional reasoning, manipulating rational numbers, basic equations, geometry, and introductory stats. That is the absolute foundation. You literally can't skip it. The enrichment track builds directly on top of that foundational layer with linear relationships, polynomials, quadratics, and advanced data analysis. It's an extension, not a replacement. Every single student has to master the core first.
To keep things crystal clear and avoid any curriculum mix-ups, the guidelines are incredibly strict about how this material is categorized and assigned. Any above-grade level material has to be tagged explicitly. We're talking labels like accelerated enrichment, above grade 7 core, algebra 1 extension, or optional challenge. It's a safeguard, you know? It makes sure no student or teacher, for that matter, accidentally wanders into quadratic equations when they should really be spending their valuable time nailing down core proportional reasoning.
There's a specific warning that comes with this curriculum, and I think it's a philosophy every educator should really internalize. Algebra I enrichment can challenge ready students, but it should not replace the foundations. Before you hand out that optional challenge, you've got to be absolutely sure your students can already interpret linear graphs and crush multi-step equations effortlessly. If that 7th grade foundation isn't rock solid, the advanced stuff is just going to crumble under the cognitive weight.
Section 2. The Algebra Pacing Guide. Now we'll map out the accelerated curriculum.
The rigorous progression of these early units requires a massive time investment. We start with a solid 6 weeks focused entirely on relationships between quantities, and then the curriculum demands a heavy 7-week commitment each for linear relationships, advanced functions and equations, and data analysis. So yeah, this maps out a highly structured long-term commitment. It isn't just a quick worksheet you hand to early finishers, it's a rigorous journey through actual high school level concepts.
And the scope? It stretches way beyond basic middle school math. Students on this track are pushed to grapple with radical equations, rational expressions, polynomial special products, and two-way frequency tables. These are complex, multi-layered topics. They require a high degree of abstract thinking and serious algebraic fluency. It's a fantastic intellectual stretch, provided the student is genuinely prepared for the rigor.
Section 3. Deep dive into linear systems. Let's bring this enrichment to life and see how it works in the classroom.
The crucial cognitive leap happens right here in the definition. A system of equations means you're considering two separate equations at the exact same time and looking for a single solution that makes both of them true simultaneously. Up until this point, students are so used to looking at just one isolated relationship. Now, they have to juggle two competing realities at once to find that one unifying intersection point. It's a completely new way of visualizing mathematical relationships. To actually speak the language of Algebra I, your students must completely master this specific vocabulary. Words like solution suddenly take on a new, highly specific meaning. Students need to confidently use and explain terms like intersection point, substitution, simultaneous equations, and ordered pair. They even have to wrap their heads around the abstract concept of infinitely many solutions. In this curriculum, mastering the precise vocabulary is just as critical as mastering the math itself. Let's walk through a quick example to see the exact level of algebraic reasoning we expect from these accelerated kids. Say we want to solve y equals x plus 2 and y equals 3x minus 4. First, you set the expressions equal to each other. X plus 2 equals 3x minus 4. Next, we systematically isolate the variable. Add 4 to both sides, and you get x plus 6 equals 3x. Subtract x, you get 6 equals 2x, meaning x equals 3. But we aren't done. You then substitute that 3 back into an original equation to find that y equals 5. So the final solution is the ordered pair 3, 5. Going through this sequence requires immense focus, working memory, and multi-step logic.
Finally, Section 4. Real-world contexts and mistakes. Let's ground this math in reality.
At this level, math can feel incredibly abstract, almost disconnected from daily life. Providing real-world contexts proves to students exactly why they need to learn to solve these systems. For instance, if you're comparing two gym pricing plans, the intersection point tells you the exact number of classes where the cost is identical. For savings accounts, it represents the precise moment both accounts hold equal funds. For moving objects, it dictates where and when they cross paths. Grounding the math in reality transforms it from a boring, rote exercise into a meaningful problem-solving tool.
Here is a brilliant practice question pulled directly from the unit because it forces students to actively verify a claim, not just calculate from scratch. Does the ordered pair 2, 5 satisfy both y equals 2x plus 1 and y equals x plus 3? Take a brief second. Think about exactly how you would prove that mathematically.
And the answer is absolutely yes. When you substitute the 2 in for the x in the first equation, well, 2 times 2 is 4, plus 1 is 5. Awesome. Now for the second equation, substituting the 2 gives you 2 plus 3, which is also 5. Since both equations cleanly output a 5, it proves definitively that this specific ordered pair perfectly satisfies both relationships. Having students check their work this way builds tremendous algebraic confidence.
Of course, with advanced material comes advanced challenges. As educators and parents, you really need to watch out for these common mistakes. Students will often find X, feel a huge sense of accomplishment, and just stop, completely forgetting they need to provide a full ordered pair. They might forget the solution must satisfy both equations or misread the visual intersection on a graph. But honestly, the absolute biggest mistake is programmatic, trying to push a student into systems of equations before they have truly deeply mastered single linear equations.
Which brings us full circle to the primary rule of the boundary. Why is this specific content labeled enrichment? Because it extends far beyond the requirements of core grade 7 readiness. It is a deliberate, highly structured step into accelerated pre-algebra and Algebra I preparation. This material is intentionally kept separate from the core pathway to ensure it serves as a sturdy, reliable bridge for those genuinely ready for the challenge rather than a frustrating stumbling block for kids who are still working to build their basic skills.
So as you plan your lessons, build your assessments, or simply monitor your students' progress, I want to leave you with this vital question to ponder. How will you ensure your students have truly mastered core equations before letting them cross that boundary into Algebra I? Thanks for joining me on this explainer, and we will see you next time.